the equation s minus 2 times s minus 3 equal to 12. First of all, we need to expand this expression here. X times s is s squared. X times negative 3 is negative 3s. Negative 2 times s is negative 2s. Then negative times negative is positive 2 times 3 is 6 equal to 12. Taking this 12 here, I'll have s squared now. Minus 3 minus 2 is minus 5s plus 6 minus 12. This is plus 12. When you cross this, it will become minus equal to 0. Since we have moved 12 away from there, everything should be 0 here. So that s squared minus 5s, 6 minus 12 is minus 6 equal to 0. Here we arrive at quadratic equation. This minus times this is minus 6s squared. Now look for two factors of minus 6s squared that can add up to this. Think minus 3x and minus 2s will give us that. But this time this will not give us this. So this cannot work. So the factors we use should add up to this middle term. And when we multiply, we should have this term here. So the only factors that can work here will be minus 6s and plus 1x. So now we know the factors. We're going to replace this middle term. S squared minus 6s plus s. We replace the middle term with this factor. Then minus 6 equal to 0. You can group this 2 by 2. Minus 6s plus x minus 6 equal to 0. S is common here. S minus 6 plus here 1 is common. X minus 6 equal to 0. We have a common factor s minus 6. Then we'll group this and this. S plus 1 equal to 0. Either s minus 6 is equal to 0 or s plus 1 is equal to 0. Hence, s is equal to 6 or minus 1. When this minus 6 crosses equality, it becomes plus 6. When plus 1 crosses equality, it becomes minus 1. 19 says, if the square root of s squared plus 1 is equal to 5 over 4, find the positive value of x. Square root of s squared plus 1 is equal to 5 over 4. Now to clear this square root sign, we need to take the square of both sides. So if I take the square of this left hand side, I will be left with s squared plus 1 equal to, now taking the square of this 5 over 4 square. Now why taking the square of this? To remove the square root sign. Remember that if I have square root of a, I can write that as a to the power of 1 over 2 indices. And I say we are taking the square of both sides. So if I take the square of this 1 over 2, I take the square of it, which I did here. These 2 will cancel these 2. So that I have a. So the point I'm making is the square of this, I have square root of s squared plus 1, which I can write as s squared plus 1 to the power of half. Then taking the square of this, that will be to the power of 2. So these 2 will cancel this. When we apply the law of indices that say a to the power of m to the power of n is a to the power of m times n. So this half multiplied 2, which means 2 can cancel out. So the point is, when you want to remove a square root sign from an expression, you take the square of it. That is the point I'm trying to make with all the long stories. Okay, now that we know that s squared, therefore, plus 1 is equal to 5 squared is 25, 4 squared is 16. Okay, if that is the case, if we cross multiply, I'll have 16 times s squared plus 1 equal to 25. By expanding, by distributing this 16, I have 16s squared plus 16 minus 25 equal to 0. So 16s squared, 16 minus 25, that should be 9 also, minus 9 equal to 0. Looking at this is a perfect square. 16 is a perfect square, 9 is a perfect square. So 16 I can write that as 4 square, then s square. 9 I can write that as 3 square equal to 0. I can apply difference of 2 square here. Remember, if a square minus b square, we can write this as a plus b times a minus b, which we call difference of 2 square. I can apply it here so that I will have 4s plus 3 and 4s minus 3 equal to 0. Meaning 4s plus 3 is equal to 0, or 4s minus 3 is equal to 0. Hence 4s is equal to, if I move plus 3 here, that is 0 minus 3, which is minus 3, or 4s, again moving minus 3 across the equality, it becomes 0 plus 3, which is plus 3. But the question says we should find the positive value of x. So since we are concerned about the positive value of x, let's discard this one right away and focus on this. Meaning dividing both sides by 4, and we have x is equal to 3 over 4 as my answer. Then the last question here says, given the expression y equal to as squared minus bs minus 12, find the values of x when a is 1, b is 2, and y is 3. Let's clear this board so we have space to work with. So if y is equal to as squared minus bx minus 12. Now we are to find the value of x when a is 1. So substituting the value. By the way, what is y? Y is 3. So let me put that also. Y is 3 equal to a is 1. 1 times s squared is s squared. Minus b is 2. 2 times x is 2x. And minus 12, which is a constant. So to solve this, let me move this term, this 3, across to this other side. So 0 is equal to x squared minus 2x minus 12 minus 3. This is plus 3. When it crosses equality, it becomes minus 3. 0 therefore is x squared minus 2x minus 12 minus 3 is minus 15. Because I can still write this as x squared minus 2x minus 15 is equal to 0. So solving this quadratic equation, x squared times negative 15 is negative 15 x squared. Now we look for two factors of negative 15 x squared that can add up to this middle term. And the middle term is negative 2x. So the factors have to be negative 5x and positive 3x. These multiplied this will give us negative 15x squared. And these added to this will give us negative 2x. So now that we know the factors, we're going to replace the middle terms with those factors so that the equation becomes x squared minus, instead of minus 2, now replace this with minus 5x plus 3x minus 15 equal to 0. If we group these 2 by 2, 5x and 3x minus 15 equal to 0. What is common here? S is common. S minus 5. And in this 3 is common. That is a number that divides both of them. 15 divided 3 is 5. 3s divided 3 is s equal to 0. We have a common factor s minus 5. we will take that, factor it out as x minus 5. Then we pair this together, s plus 3 equal to 0, 1. Either this is equal to 0 or this is equal to 0. Therefore, s is when this cross to the other side become plus, and when this cross to the other side it becomes minus.